This is a Chapter 4, Section 1 review, textbook pages 86 through 91. So the first part of this section talks about Gregor Mendel, and we know that he was a scientist. He was born in 1822 in Austria, and he grew up in a farm, which is where he learned about plants. But when he turned 21, he went to a monastery to study science, because that's what he wanted to do. And while he was in the monastery, he investigated the heredity in pea plants. So the first part is knowing the difference between self-pollination and cross-pollination. And let me draw a picture for this. So here we have a plant. We know that some plants have both female and male structures. And I'll go ahead and draw the plants for cross-pollination as well. So I'll need 2 plants for this one. Okay. So in self-pollination, we know that the anther carries the pollen, which is the male reproductive cell. So what can happen is that the wind can come. It can be wind, or there can be an animal like a bee, and it can move this pollen around. So this pollen can be transferred from the anther to the pistil and then fertilize an ovule, which will then turn into a new plant. But in cross-pollination, what can happen is that the pollen from one plant can be transferred over to another plant, and that would be cross-pollination. So the difference between self-pollination and cross-pollination is basically that in self-pollination, the plant pollinates itself. So the plant pollinates itself, whereas in cross-pollination, so the plant is pollinating itself, whereas in cross-pollination, one plant is pollinating another plant of the same kind. And when we talk about true breeding is when the self-pollination happens with the perfect plant, then all the characteristics or traits from the parent plant will be the same in the offspring plants. So Mendel, he wanted to experiment with characteristics and traits. So the first part was you have to understand the difference between characteristic and a trait. So these are two important features or 2 important vocabulary words that you should know: the difference between characteristics and traits. And we know that in characteristics, an example would be a feature, so a hair color. But in a trait, it's more specific. It's like red hair, or brown hair, or curly or straight hair. So Mendel decided to experiment with both through self-pollination and cross-pollination. And through cross-pollination, because he wanted to make sure that the plants didn't self-pollinate themselves, he removed the anthers so that wouldn't happen. Mendel experimented with pea plants because they were a good option. There's many types of pea plants, and they're also very available all over, and it was easy for him to experiment with that plant. So what he did was, he took 2 true-bred plants, meaning that they had identical traits as the parents, and he bred them, or combined them to make another plant, and he called this the first-generation plant. So what he observed was, when he combined a true-bred purple plant with a true-bred white plant, that the offspring would be purple. And the reason for that is because purple is the dominant trait. But then what he took is he allowed the first-generation plants to self-pollinate, and what he saw was that in this case, the recessive trait appeared, which means that the white, the recessive color, would reappear. And he determined that the ratio was 3 to 1, which meant that when he did the self-pollination of the second generation, 3 plants would be purple or dominant, would carry the dominant trait, and 1 plant would be white or carry the recessive trait. So it reappeared. Here are some examples of recessive and dominant traits. So you might want to check if you have any of these. It's probably because one of your parents has one of these traits. Now, even though it took 30 years after Mendel's death to get recognized, his efforts are still widely used today, and modern genetics is a growing career in science. So please go over Chapter 4, Lesson 1, and I hope to see you on Monday.